Moving on, let's officially define what RFID is. RFID stands for radio frequency identification. At its core, it is a form of wireless communication. But how does it work without a wire? It relies on electromagnetic or electrostatic coupling. Essentially, it uses the radio frequency portion of the electromagnetic spectrum to pass signals back and also forth. The ultimate goal of this technology is simple: to uniquely identify things, whether that is an object, like a product in a warehouse, an animal, or even a person. Yeah. Next, we go to RFID history. Early 19, the root scientists first began using radio wave to identify and also track objects. 1973, the first patent Mario W. Cadulo patents the first modern RFID system. 98 to 99, industry used active and passive RFID system evolved for military and supply chain tracking. 20, going mainstream teach becomes affordable, expanding into retail, healthcare, and also transit. Today and also in the future, the connected future RFID merged with NFC and LOT to create smarter everyday technology. We have two components of RFID. Number one is RFID reader. RFID reader is a device that uses radio wave to wirelessly communicate with, identify, and also track objects or people by reading data from RFID tags. Number two is RFID tag. RFID tag is a small electronic device consisting of a chip and also antenna that transmit data wirelessly to a reader via radio wave. We also have two main types of RFID tags. Number two is passive tag. Passive tag doesn't have its own power sources and it relies on the energy transmitted from the reader to active and transmit its data. Number two is active tag. Active tag has its own power sources, typically a battery, and it can transmit data continuously even when it is not close proximity to the reader. Next is a step showing how an RFID reader communicates with a tag. Number one, the RFID reader sends out continuous radio frequency, or we call it RF, wave through its antenna. This creates an electromagnetic field around the reader. Number two, when a passive tag comes within range, its internal antenna intercepts the radio wave. Through electromagnetic induction, this RF energy is converted into a tiny electrical current, waking up the tag's microchip. Number three, once powered, the reader modulates its signal to send a specific command. Number four, instead of broadcasting its own signal, which requires a battery, the tag is a trick called backscatter modulation. It changes its own antenna electrical impedance, which alters how it reflects the radio wave back to the sources. Number five, the reader catches this reflected variation, decodes them back into digital data like an ID number, and pass it along to a computer database or application.
Next, I will explain the application of RFID in tolling and transportation. RFID technology enables automatic toll payments. When a vehicle passes through a toll plaza, the RFID tag attached to the vehicle is scanned automatically by an RFID reader. The scan ID is then sent to a central cloud server, which deducts the toll fee directly from the user link account or e-wallet. A common example in Malaysia is the Touch and Go RFID system. This system helps reduce traffic congestion, save time, and provide a smooth driving experience. Another important application of RFID is in healthcare. Hospitals use RFID wristband to track and monitor patient location within the hospital. Each patient wears a wristband containing an RFID tag with their information. This allows healthcare staff to quickly identify patients and ensure they receive the correct treatment and medication.
RFID use small RFID tag attached to product and radio wave to identify and track them automatically. One important application of RFID is inventory management. RFID allows business to track inventory in real time, so they always know the location and quantity of their products. Compared to manual counting or barcode scanning, RFID can scan many items at once, making stock counting much faster. RFID also reduces human error because inventory record update automatically. In addition, it helps prevent stock loss and theft by monitoring the movement of products. So overall, RFID improve warehouse efficiency, save time, and help businesses manage their inventory more accurately.
Other than that, one common application of RFID is access control. RFID technology is widely used in schools, office, hotels, and restricted areas. Users are given an RFID card, P4 or ID badge containing an RFID tag. When the card is brought near an RFID reader, the reader detects the tag and sends information to the access system control. If the user is authorized, the door unlocks automatically. This provides a fast, convenient, and secure method of controlling access without the need for traditional key. For example, many office buildings use RFID employees card to allow staff members to enter certain areas. Universities may use RFID card to restrict access to laboratories, while hotels use RFID card to unlock guest rooms. This helps improve security because only authorized individuals can enter specific areas. RFID offers several advantages compared to traditional barcode systems. First, RFID is faster because the tag can be read automatically without direct contact or line of sight. Second, RFID can operate over longer distances depending on the type of tag used. Third, RFID tags can store more information than barcodes. Finally, a reader can detect multiple RFID tags at the same time, making data collection much more efficient.
Although RFID offers many benefits, it also has some challenges. First, the implementation cost can be high because the company needs RFID tag, reader, and system software. Second, RFID signal can sometimes be affected by metal object or liquid, causing reading errors. There are also privacy and security concerns because authorized users may access RFID data. In addition, some RFID systems have a limited reading range. Looking to the future, RFID technology is expected to become more affordable as the cost of tag decreases. RFID will also be integrated with Internet of Things, IoT, and artificial intelligence (AI) to provide smarter tracking and data analysis. Security features will continue to improve and making RFID systems safer to use. As a result, RFID is likely to be adopted more widely in industries such as retail, healthcare, transportation, and logistics.